I know we've already finished the front of page 26, but I want to start a couple. I'm going to put a couple up here just to make sure that we haven't forgotten everything that we talked about, you know, whenever that was a few days ago. So let's see if we remember how to do a problem like this. The log base 3 of 9. Can anybody tell me what the answer to that is? You were getting really good at them. It's 2. And it's 2 because 9 is 3 squared. And these cancel, so the answer is 2. Now, you have to be careful because sometimes you have to do tricky things. Like, what's the answer to this one? Negative 2. And why is it negative 2? Because 1 over means the exponent is negative, right? Remember, negative exponents mean 1 over. So the fact I have 1 over means my exponent's going to be negative. 49 is 7 squared, right? So my answer is negative 2. If I wrote all that out, it would look like this. Which you do not have to write all that out, but that's what's going through your head. That's what you're thinking. So let's try one more. This is the tricky one. See if you remember this. Anybody remember that one? That's the hard one. 0. And the reason that it's 0 is because 1 can be written as 8 to the 0th power. The only way to turn an 8 into a 1 is to raise it to the 0th power. In terms of powering, the only way to do it is to raise it to the 0th power. So what if this were a 7? What would the answer be? Still 0? And in fact, it doesn't matter what this is. That base can be anything. If you take the log of 1, you're going to get 0. Everybody kind of remember that from the other day? Okay, then let's get our calculators out. And let's do these calculator problems on the back of page 26. Evaluate with a calculator, round to the 10,000th. Okay, how many decimal places is the 10,000th? Let's see, the first decimal place is the 10th, and that would be the 100th. And that would be the 1,000. So that one is the 10,000. So you're going to round off to 4 decimal places. So we want the log of 8.61. No trickiness. We press log 8.61. And well, how are you going to write your answer? 9350. Yep, that's exactly how you're going to write it. That's it. That's all there is to it. Now the next one says ln 12. We have an ln button, right? So we'll press ln 12. Did you get 2.4849? Okay, don't make it hard. You press ln 12. All right, how about C? Can you press that one for me? No solution. Boys and girls, you cannot take the logarithm of a negative number. So when you have log or ln, this guy right here, whatever this number is, has to be positive. You cannot take the logarithm of a negative number. So C is no solution. Some of you are going to notice that. Some of you are going to go ahead and type it in. If you type it in, it gives you an error message, right? No solution. Okay, did you get an answer for D? What'd you get? 1.1895. How about E? Negative 3.1355. I hope if you have a calculator, you're punching along with me. Joseph, that would be you too.
Yeah.
How about F? No solution. If you missed it, there's a negative there, right? No solution. How about G? No solution. And the last one, 3.2960. Does everybody feel okay about that? Pretty easy. We'll be using our log button, our ln button, just depending on which the case is. Okay, next section. Oh boy, these are some logarithmic equations. Now we are solving equations that have logarithms in them. This is the most important thing I have said to you in a very long time. This is big news. This equation needs to be rewritten. The minute you see it, you're going to rethink it. And this is how you're going to rethink it. You are going to translate this equation into this. Now, before you start freaking out, the symbol LOG means there's an understood base of what? 10. So there's a 10 right there. Write it in if you want. There's a 10 there. Every time you see LOG, if there's no number, it's a 10. The way you rewrite your equations is, watch how I'm doing it. You take this number, you start with this number, you raise it to this power, and it equals this. So see how it makes a loop? You start with this number, you raise it to this power, and it equals this. So this is 10 cubed, which is 10 times 10 times 10. So the answer to the question is 1,000. Every time you have a situation that looks like this, here's another one. You're going to think of a 10 being in that spot right there. And then you're going to rewrite it. And how do we rewrite it? We start with this number, so we start with 10. And then what do we do with it? Raise it to this power, and it equals that. So what's 10 to the negative first mean? 1/10, 1 over 10. So the answer to the problem is 1/10. All right, can you do C? Remember, there's a 10 there. Write it in. Anytime you see LOG with no base, write in a 10. So can you rewrite that? 10 to the negative second equals x. We start here, write down that number, raise it to this power, and it equals that. What's 10 to the negative second mean? 1 over 10 squared, which is 1 over 100. Now I'm getting wild and wacky again. ln. What's that a symbol for? Who remembers? It's log base e. This means log base e. Every time you see an ln, you think of it as log base e. That's what ln is. Now you can translate it the same way as the other ones, only now we're going to start with e to the 4th equals x. Good news is leave it just like that. The answer is e to the 4th. If you want to type that in and get a decimal, you can, but this will probably be a no calculator problem, so we'll just leave it as e to the 4th. Anybody got the next one done already? E to the 6th.
Yeah.
It's the same problem. Isn't it just going to be e to the 6th?
Yeah.
Remember, we write this number down, we raise it to this power, and it equals that. Ooh. That scares me, and I'm fearless. What do we do?
10 to the 30 times 3 times 3.
Actually, we can't do anything until we take care of this 3. What do you think we might do with that 3? Oh, maybe we would divide both sides by 3? So then our equation says log x equals 1. What's the base on that? 10. So when I translate that equation, I start with the 10, I raise it to the first power, and that equals x. So what's the answer to the question? 10. Good. G. Take a clue from the last one. How do you think we'll start? Divide by -2. So we have ln x equals -2.
Yeah.
Now remember, the base here is e, right? So when I translate it, I start with the e. You start with the base. So e to the -2nd equals x. What's negative exponent? What do I do with that? 1 over. So the real answer will be 1 over e squared. We still aren't going to get a decimal or a number or anything, but it's going to be 1 over e squared. Remember, when we see log, put a 10 in there, and here we go. 10 to the 1/2 equals x. What's 10 to the 1/2 mean?
Square root of 10.
Square root of 10. Remember, fractional powers mean radicals. This tells me I'm taking the square root to the first, right? I
10 to the 1/3.
yeah. We're going to start by saying 10 to the 1/3 equals x. And what does 10 to the 1/3 mean?
Root of 10.
Cube root of 10. Remember, fractional exponents are radicals, and the denominator tells you which root to take. So a 1/3 means a cube root. One more in this section, and you've done a great job. ln x equals 1/4. Now, base is e on that one. Base is e. E to the 1/4 equals x. And what does 1/4 mean? 4th root. So x is the 4th root of e. Hey, oh, don't pack up. We're going to do a couple more. Listen, I don't see you guys for a long time. I got to pack in every minute I can here. All right, we won't get through this next section, but we're going to do a couple. It says write as a single logarithm. Don't make this hard. It's not, but there are a couple rules you need to remember. When we have a subtraction problem, and it says write as a single logarithm, that means 1 log. So somehow I have to take these two and squish them together. When they get squished together, they go together as a division problem. When the logarithms are subtracted, it means the numbers themselves have been divided. So you're going to take this expression and you're going to rewrite it like this. That is actually a property of logarithms. So I'll just do this one over the side. If I had the log of A minus the log of B, I would put those together as the log of A over B. And if I had the log of P squared minus the log of Q cubed, I would put that together as the log of P squared over Q cubed. Okay? Okay, that's our next problem. Let's look at the next one. Now, exactly. Now, the next one, there is a complication in it. So let me not do the next one just yet. Let's say we had log x plus log y. Just that. That 2 is a complication we're going to deal with. If this is what we had, we could put them together, but since it's an addition, they're going to go together as a multiplication. Now, the problem on the sheet, though, has this crazy 2. You cannot divide it out. First of all, this isn't an equation. And second of all, if you did divide, you'd just be stuck with it here. Do you see that? So we're not going to do that. We're not going to divide it out. What we're going to do is recognize another property of logarithms, which is this guy right here. A coefficient in front of a logarithm actually represents an exponent. So this would be written as the log of x squared. If there's a number out in front of your logarithm, you can pop it up as an exponent. Now I can put those two together. Since they're added, it will go together as a multiplication, so it will be x squared times y. Now we're going to spend more time on this the next time we're together, but one final problem I want to leave you with to kind of wrap it up. What if we had this? Could you look at that monster? Could you put that together as one logarithm expression? First of all, you'd put this up here, right? And you'd put this up here. Now, what are you going to do with the x squared and the y? Multiply, and what are you going to do with the z cubed? Divide. So it would be x squared y over z cubed. So you can do some pretty complicated things if you know your rules.
Why do you divide the C?
Because it's a minus. And remember, when it's minus, we divide. Okay. All right, now listen. Ethan, would you turn that off for me? Thank you. I don't know what I see here. Hopefully Monday.